Hello, my name is Daniel Waters. I'm a fourth-year student at Western Michigan University Holmstrom MD School of Medicine. My co-authors on this paper are Lucas Rich and Dr. Christopher Cater. So the title of our presentation is Does SarsCoV2 Downregulate the Vitamin D Receptor in Humans? I have a full abstract there, but briefly, our objective here is to investigate the possible role of vitamin D receptor in the pathophysiology of COVID-19. We do intend to explore this topic further in a more complete manuscript. As you can see, a lot of this is beyond the scope of a presentation like this. So our methods, we did a number of searches at PubMed, including some of these terms, but of course, when you start searching, you find other things to look for as well, so they're not limited to that. So as far as vitamin D and COVID-19 goes, many studies have tried to see the association between serum vitamin D levels and COVID-19 outcomes. A recent meta-analysis of 31 studies showed that it could not find a statistically significant association there. There were some positive trends in risk of mortality in ICU admission and invasive ventilation, but again, they weren't statistically significant. A small pilot study did show that vitamin D supplementation did reduce ICU admission. Many other studies are ongoing. So one of the drugs that we have seen work is dexamethasone, and it's been shown to decrease mortality in COVID-19 patients by Horby et al. However, part of the way dexamethasone works is it can increase the transcription of the vitamin D receptor, which increases the effects of vitamin D3. That was shown in 2011. So other viruses do downregulate the vitamin D receptor, and this is a short list, by no means exhaustive, but Epstein-Barr virus, rhinovirus, RSV, respiratory syncytial virus, and hepatitis B. What many of these viruses have in common is they depend on the human protease furin in some way. So if you remember the SARS-CoV2 mechanism, it depends on the furin protein to activate the spike protein, and then ACE2 is the target of the spike protein. And a study by Glinsky used genomics to show that the vitamin D receptor negatively regulates both furin and ACE2 through the HNF4 alpha pathway. Other effects of the downregulation of VDR, including from some knockout studies, show thrombosis, vascular dysfunction, cardiac injury, neurological injury, including smell and taste effects, and hypertension. All of which we see in COVID-19 patients. So one possible mechanism is something called heat shock protein 70. It's a chaperone protein, and it's regulated by the vitamin D receptor. And it's been shown that it's important in the pathophysiology of COVID-19. So what else do we know? So what about the bats? So it's generally accepted that the SARS-CoV-2 virus came to humans from fruit bats. If you think about it, fruit bats generally live in the dark and eat fruit. So this suggests a possible difference in the vitamin D metabolism compared to humans. An Egyptian fruit bat was measured to have almost no vitamin D. And the family of bats associated with SARS-CoV-2 has a normal body temperature of 41 Celsius. This is made possible by a heat shock protein, orders of magnitude greater than humans. And so what we see is in bats, the heat shock response does not depend on the vitamin D receptor the way it does in humans. So it's another possible difference. So in conclusion, the hypothesis that SARS-CoV-2 virus downregulates the vitamin D receptor will provide a single mechanism consistent with all of the following: the equivocal vitamin D studies, the dexamethasone efficacy, the prevalence as a mechanism used by other viruses, especially those using furin-dependent activation, a potential upregulation of ACE2, the target of the spike protein, and thrombosis, cardiac injury, and neurological injury. And it would also explain how bats can carry the virus asymptomatically.